Okay, so a precipitate. A precipitate is a solid that will form in a solution when two ionic salts are mixed together in an aqueous solution. It will create this precipitate. So precipitate means a solid component of it. So what will happen is the ions, or let's say the cations, will switch of the two ionic components that are mixed, and then that product of those ions switching is an insoluble product based on our solubility rules. So this reaction, potassium chromate is added to barium nitrate. So we have K2CrO4 plus BaNO3 2 is going to yield. So what happens with this reaction is the cations will switch, or the anions will switch, however you want to look at it. And you'll end up with KNO3 plus barium chromate. Now, the charge of chromate, what's that? -2. So it'll just be, and barium is what? Yeah, +2, because it's with two nitrates. So let's do some balancing first. You have 2 Ks here, 2 Ks there, and then, okay, it's all good. Now, which one will be our precipitate? The second one. Good. That's because the rules we went over, I stressed potassium. Anytime you see potassium, soluble. Anytime you see nitrate, soluble. You put them both together, super, super soluble. So one will definitely be an aqueous solution. It'll be in the aqueous solution. You won't see anything, meaning. So if you were to do this reaction, this yellow that you see, that would be the barium chromate. The potassium nitrate won't actually form. It won't be potassium nitrate. It'll just be free potassium ions and free nitrate ions. Meanwhile, the barium chromate will stick together, because they will stick together and what we call fall out of solution, meaning they will no longer be part of the aqueous pluses and minuses. They will become a solid and fall out of the solution. When you're given one, the question you're going to be asked is to find the net ionic equation. Okay, so we'll just talk about this one. We already did it. So we have the same reaction here. We have the potassium chromate and the barium nitrate make the potassium nitrate and the barium chromate. We know the barium chromate is a solid. So S doesn't stand for soluble, it stands for solid. The AQ means it's soluble. The next step we do is, after we have the overall formula, is we can create something called the complete ionic equation. It tells you the representation, or the accurate representation and behavior of each of these ions in an aqueous solution. So whereas the overall formula equation doesn't. So the complete ionic equation, once we split it apart, will tell you, if I look into this water and take a scoop of this water, what will I see? And you won't see potassium chromate, I'll tell you that. What you will see is, you'll see for every 2 potassium ions that are separated, you'll see a chromate anion. So what I'm doing is I'm splitting apart the ionic components that are aqueous. Now, the reason why you have 2 potassium is because you can't have K2. So the reason why it's K2 and then chromate is because there's 2 potassiums bonded to that chromate. Once they all dissociate from one another, you can't have K2, it'll just be 2K plus. And we know that barium nitrate is also soluble, so we would put barium 2 plus AQ. And the notation here is important, even though it's kind of technical. You have to write the charge, the amount of them as a coefficient, and then the AQ. And then you have 2 nitrates, 2NO3 minus AQ yields. Now, since potassium nitrate is still soluble, you have 2K plus AQ plus 2NO3 minus AQ plus the solid. Now, the solid does not break apart, because if you take a sample of this solution, the barium chromate will be barium chromate, because it came out of the solution. It did not dissolve. It is no longer the ability to dissolve. So you'll have BaCrO4 solid. And that is your complete ionic equation. So it's an accurate representation of, on the molecular level, what ions do we see, which ones are bonded together, which ones are not. And basically, the way this works with all precipitation reactions, you're going to have 4 free aqueous ions. In this case, you have potassium, chromate, barium, and nitrate. Some combination, or really one combination of those cations and anions will create an insoluble component. That insoluble component is the precipitate. That is how the reaction occurs.